All right, welcome. Good morning, everyone. My name is Annie Burgess. I am the ESIP Lab Director, but I'm not going to speak too long this morning. I just wanted to say hi and say it was my pleasure to pass the mic over to the ESIP Vice President, who many of you may know, but if you don't, I'll introduce Denise Hills. Denise has been a long time ESIP participant and enthusiastic supporter of our community, often participated in Funding Friday. So she will be our MC this morning and tell you a little bit about how this will work. But first, I want to check to make sure that all of our presenters are here. Well, actually, Denise, why don't you kick it off and I will look to make sure our presenters have all logged on while you're telling a little bit about
Funding Friday has been going on with ESIP for longer than I know. It was originally, it happens every summer, every July meeting, because people tended to drift off at the end of the meeting. And this was a way to encourage people to stick around through, to see all the great things that are happening on the last day. These are small grants to members or to students or teachers. $5,000 for members, $3,000 for students or teachers to do a small project that they then present on either at the following January or July meeting. And it's been a great way to get people more engaged with ESIP. It's often people's first ESIP. They decide, oh, wow, I met some people and I really want to do this great project. And it's been very inspiring to see some of the really great things that have come out of these projects. Some have led to longer term grants or longer term projects. So it's been really wonderful to see. And it is really, truly my honor to be kind of the MC and host for the brief presentations. Usually what we do when we are in person, we go around to each poster and everybody gives a little 2-minute spiel. But virtually, it's a little hard to go around in person to posters, and posters are a little bit different. They're created when we're in person, they're often a sheet of paper and markers or crayons or Post-it notes and all kinds of really creative things. And it's always really wonderful to see people's thought process in this. But what we're going to do is we have slides of each poster. We're going to hear a 2-minute pitch from all of those who have submitted a poster and potential project. Then we'll be given some time to, after those 2-minute pitches, we'll be given some time to go interact with the posters over, 20-30 minutes or so. And then you'll be able to vote. For those of you who have experienced this in the past, you know that you get 3 votes. You get 3 votes for members. You get a total of 6 votes. You get 3 votes for members and 3 votes for teachers or students. Voting will be via a Google form that is available through the Kiko chat for the Funding Friday posters. And it will only let you give 3 votes for each category. Voting needs to close before our speakers start at about 11:50. So be sure to get your votes in. Annie just shared the link to the Kiko chat for Funding Friday in our chat box. And Annie, if we're ready, or if I've forgotten something, what have I?
No, I think we're ready to go. So if our Funding Friday submitters could take a look at the posters in the Funding Friday space and kind of see where you're going to be. The first one up is Mimi, and I love Mimi's poster. So what I'm going to do is I'm going to share my screen, and can everyone see a poster? This is our one handmade poster that I love. And let's see, Mimi, are you? And again, this is, I will emphasize the fun and Funding Friday, that these are folks that have taken time, that are enthusiastic enough about these subjects to make a poster. So it is really great to show some love, share in the levity that they often bring to these presentations, and enable us all to have a little bit of lighthearted collegial fun on a Friday morning. So I'm just bringing that spirit myself to this. And I have a timer here that I'm going to, as soon as you start, Mimi, I will start the timer and you'll hear a ding at 2 minutes. So are you ready?
Yep, I'm ready. My
Okay.
daughter, who's a student, is also going to join. She's behind me.
Okay,
Yeah.
great.
Yeah.
Well, whenever
Okay.
you start, I'll start the timer.
Okay, great. Okay, thank you for this opportunity. I know I have to speak really fast, which is great because I'm so excited. The teacher workshop had wildfires, which was like so personally and professionally like awesome, because my son, who struggled in school with dyslexia and is now at University of Washington, became a wildland firefighter this summer and wants to go back next year. And he's super excited. I talk to him all the time. And he is studying to be a teacher and American Sign Language. And he would like to be a part of my Funding Friday grant if I get it, because I'd like to partner with my biology teacher friend, Erin Fiorini. She teaches 9th grade, but she would include my class, which my class is 9th through 12th graders that have reading, writing, math disabilities, as well as behavioral disabilities. So they often spend a lot of time either suspended or with me. I taught in person. I was one of 3 teachers out of 110 that taught all in person last year, October to June, through COVID. So my students were with me in my classroom. So the 3rd week in September, I would love for them to get out into Erin's classroom and be out with the general population again and learning about geohazards. So I learned about it through the Concord Consortium presentation. I already have my class registered, my teacher registration. There are such cool things on that website. The coolest thing was the simulation, which is a lot like a video game, I think. And so we would be collaborating with her gen ed kids and my group of 12 special needs kids. And we would do this whole unit. And then our culminating activity after my son comes to speak, we would all, her class and my son would all go on a field trip to Mount Rainier, which is right near us. My kids are the lowest socioeconomic group, and many special needs because of their family situations. They don't go hiking. Many of them have never been fishing or to the outdoors. So this would be a way for them to learn about the outdoors, but also learn about risk factors and assessing things, and then
Ding,
preserving
ding,
their environment.
That's 2 minutes.
Thank you. Thank
Everyone
you.
on you. Woohoo!
Bravo.
All right. Well done, Mimi.
Thank you.
Very exciting. All right.
All right, so our next speaker is Eric with a student-led conference.
Okay. Let's see. Do we have Eric?
I'm here.
There we
Spotlight?
go.
Okay, just a sec here. Sorry, I should just keep my screen sharing on and not keep turning it on and off. I will do that next time. All righty, Eric, poster number 2.
All right. So thank you so much for having me as well. I just want to say I have no artistic skills whatsoever. So I'm impressed with the artwork of others. I'm from Marymount School of New York. We're a K-12 all-girls independent school in New York City. And I'm asking for funding on behalf of my students to support the 2022 Youth Climate Conference. This is going to be the first annual virtual conference. It's modeled after our highly successful STEMX Youth Summit. It's scheduled for July 9th, 2022. It's open to high school students and teachers worldwide. The students in my senior elective atmospheric science are the conference managers, the project managers. They do all the planning. They run the entire event, everything from the schedule to PR to registration to speaker requests and outreach. They basically run the whole show. We partner with the Religious of Sacred Heart of Mary NGO at the United Nations. with 21 schools in our network across the globe and some schools in Australia to build our global reach. And our conference is going to have keynote speakers, data scientists, Ignite sessions for student climate researchers. But most importantly, the workshops, which are going to be developed and run by the students, will feature ESIP teacher resources such as En-ROADS, educational resources from climate.gov, and activities from the Climate Literacy Engineering Awareness Network, which is CLEAN. These are all resources that we regularly use in class. So basically the students are running the workshops as well. The funding is going to support an interactive conference platform, PR materials, and presenter stipends. And our goal is also to support the participation of 1 or 2 schools with underrepresented populations so that we can provide access to them as well. So I just want to thank you for your consideration. And I think I did that under 2 minutes.
You did.
Thank you so much. I appreciate it. This was a great experience.
Good job, Eric.
Yeah, next up, we have Jessica with multiple point of interest walk.
Hello, can you hear me okay?
Yes, we can.
Okay, sorry.
Yeah.
Just let me know when you're ready.
I'm starting the timer as soon as you start talking.
All right. Well, I'm not very artistic. I kind of like to go out and just play in the dirt and have the kids do the same thing. So I'm sorry my poster is a lot of information, but good morning. My name is Jessica Elliott. I'm a 7th grade integrated science teacher in a very small, very rural school system in Kentucky. We are fortunate enough to have a combined middle and high school campus with a huge shared athletic fields with a lot of different elevations here. And we have a lot of room for our students to roam. Unfortunately, we don't have a lot of reason for them to roam. And that's why I'm trying to get the funding Friday and hoping to get ESEP's help. I want to get my students outdoors and looking at the earth, at least our little part of it. I'm proposing a sort of guided tour of the topography and features of our campus. Significant points of interest will be selected, and the students in our science club and enrichment will research and create web pages that can be accessed with a QR code. Each point will include an online question that students can answer. I'll be modeling the first 2 or 3 as I have definite specific information that go with our NGSS standards and also go with our school's geothermal heating and cooling systems and the differences in the magnetic and electric fields in our campus. You know, that crowd mag was awesome. I just did a thing of our football field this morning. You can see a lot of differences in there. And the weather and erosion patterns are really significant sections of our campus as well. The walk is accessible to anyone that has a smartphone. It's a scavenger hunt kind of style. Parents and families will be encouraged, and it's a good break for our community members during half times, waiting around after practice to finish, really anytime anyone's on the campus. In order to make the stations weatherproof and tamper resistant, I want to make them out of heavy duty materials. I need it to be permanent. I don't want to just do this and do it as a cutout and a printout and the kids forget about it the next year. I want this to be something that we last and build on. Sorry, it's cool.
Okay.
Hooray! Yay!
Bravo.
Excellent. I always love these presentations so very much because just the passion and the excitement and just what people are thinking to do is just amazing. So now we have Becky with Citizen Science School Garden.
Thank you. Hi, everyone. I'm Becky Walters, and this is my project where we're putting data in the hands of our students. So in the 1970s, 2 biology teachers at our school, LaFollette High School in Madison, Wisconsin, built an arboretum. And the purpose of the space there was to provide like a natural teaching environment and save on field trip costs, but also the benefit of better water quality and anchor the soil, provide wildlife pollinator habitats and so forth. Unfortunately, this space is not well utilized at our school. So with the Funding Friday mini grant, we would make this arboretum an interactive space for our students in our community. Students can visit a Wisconsin hardwood forest, a prairie, and a pond ecosystem. They'll collect and share data and then conduct research using real-time, scientifically sound earth science data. So we'll put purple air sensors and rain gauges in the area and then provide QR codes throughout where students can collect air quality data for environmental awareness using the purple air, connect the community with geomagnetism using the CrowdMag app, engage in rain gauge collection and reporting using CocoRAS. They'll complete individual research projects and use this data to participate in the JPSS Virtual Science Fair that's happening this fall. In addition to this, we would work on building community vegetable garden beds for people in the area, like make a connection with our community that way, which would provide healthy vegetables, promoting the lighter carbon footprint, and then explore the En-ROADS model to educate themselves on how this is like one easy way to slow the climate change and hopefully lower that temperature. We would use the money, we would purchase the rain gauges and the purple air sensors. We would also, similar to the last presentation, create QR code stands that are like material that can withstand a Wisconsin winter. We would use money to create the website where it would link to all of the different data that's available for students and community. We would put some money into providing more native plants into our area and fixing up our pond has gotten a little bit overgrown and needs some. Thank you for this time.
So hard to cut these off. Great job, Becky.
Great job,
Woo!
Becky. Great job, everyone. So those were the 4 presentations from our teachers. And now we're going to be moving on to posters from our ESIP members. First up is Megan with combined databases for better info.
Hey there, can everybody hear me? All right. Okay, great. So I want you to imagine with me really quickly that you're a volunteer at an environmental justice group and you're worried about drinking water and drinking water sources in your community. After using data from EPA's enforcement and compliance history online with the Environmental Enforcement Watch, you know your municipal wastewater facility and a few other industrial facilities emitting into your watershed have had some Clean Water Act violations, but you're not really sure what that means for your drinking water. You do some more searching and realize the CIDWIS database might be a good complement to ECHO data, but you're having trouble finding the answers you need and understanding if the violations are connected to declining water quality. At the Environmental Enforcement Watch, we have had conversations about a wide array of environmental and public health concerns, just like this, with individuals and environmental justice groups. There are wide gaps between what EJ groups need to know and what data ECHO can provide. I want to have one-on-one user meetings with several of our existing EJ groups to better understand what additional data would help them do their work better, and then take those needs to federal, state, and citizen science databases and see if, by utilizing data from multiple sources, we can answer questions like these. If we found this successful, our next step would then be to integrate these databases into the data infrastructure we have already developed for ECHO, making the data as accessible as possible to the groups and individuals through Jupyter Notebooks, reports, and our website. This grant would allow us to have these critical meetings with our partners, as well as really dive into different databases and see if we can make the data compatible and powerful for our partners. So that was really quick. That's all I have. But thanks so much. And it's been really great to hear all of the other proposals.
Thank you, Megan. That was excellent. Yay! It's so hard to give applause over Zoom. Right. Up next is Ryan with Space Weather.
Excellent. Thanks so much, Denise. I would like to pitch a project to bring the space-based perspective to the Earth Science and Informatics partners. And I want to do that by starting with a story. So if we backtrack to March 7th, 1989, in the Quebec province in Canada, there was a massive snowstorm, which is not unusual to that area, but those snowstorms do stress our human natural systems. What happened was a week later, the sun created this massive solar eruption, one of the biggest that we have in modern records. And it created a huge space weather storm that, coupled with the terrestrial stress on the systems pushed the power grid in Quebec over a tipping point and resulted in blackouts that affected and had cascading effects for all of our systems and across our population. And so what we recognized at that time was the importance of space weather, specifically in connection to our Earth and terrestrial sciences. Over that time, we've started to track who is interested and concerned with space weather. And so you can see there's been an exponential growth in space weather customers, people who need to pay attention to the space weather environment. And that comes from everything from the aviation industry to the power grid to anyone connected to space-based technologies like communication services. Over that time and in more recent years, we've seen international and bipartisan, if you can believe that that's a thing anymore, recognition of the urgent need to understand space weather. And from the ESIP perspective, the sun and the earth are inextricably linked. And it's very important that we bring this perspective to the ESIP environment. The problem is space weather data exist across this entire solar terrestrial system and really solar planetary system. And the glossaries, the vocabularies, the descriptions that we use to describe those are very disjointed. These exist in many forms in many different locations, and there's very little connection, very little harmony, no integration, and there's very little connection to the earth sciences, where ESIP has developed a very rich understanding and some very nice ontological community environments for the earth sciences. What we propose to do with this project is to take that first step towards harmonizing and connecting other glossaries. Thank you very much.
Woo! Yay, Ryan. That was great. I agree with Douglas. We need sound effects in Zoom to make it more satisfying to provide applause to all these great speakers. Our final but not least poster up today is from Thilanka with Identifying Vulnerable Facilities.
Hi, I'm Thilanka Munasinghe from RPI. Our project is identifying vulnerable facilities due to extreme effects on precipitation. Climate change has prominent effects on critical infrastructure such as hospitals, power grids, and bridges. Increased frequency in intensity of extreme weather events such as flash floods, rainfalls, triggered landslide caused by climate change make those critical infrastructure very vulnerable. Identifying those vulnerable infrastructure and their location helps stakeholders to alert and prepare early in order to minimize these adverse impacts. So far, we have implemented a machine learning-based clustering approach to visualize the vulnerable healthcare facility locations on the interactive dashboards. We use NASA Global Precipitation Mission data, IMERGE, Homeland Infrastructure Foundational level data on hospitals, urgent care centers, blood transfusion, dialysis center locations in our dashboard. Now, in this project from this grant, we plan to integrate additional data layers such as weather station data, information on historical flooded locations, incorporate social media data such as Twitter data on flooding and mudslide information into the existing dashboard. We intend to create a toolkit and a system to identify and alert high vulnerable regions and areas. We plan to release the assets of this project as an open science project, generate containerized environments with Jupyter notebooks and GitHub repositories so that ESIP and other scientific and academic communities can use it as an open science project. Our project collaborators are Jennifer Way, Bonita Casey from NASA Goddard, Agbeli Amico, Keith Merle from ENCA, Kathy Fontaine from RPI. Thank you so much. Right on 2 minutes.
Yay!
Yay! Thank you so much to all of our presenters. They were all fabulous, and it's going to be hard to vote. So just a little reminder about how voting works. There is a Google form. I've dropped the link in chat a bit higher up. If you still need it, let us know. Now you can vote for the same project multiple times. You can allocate all 3 of your votes to the same poster. Remember, there are 2 categories, the teachers and the members, or you can spread your votes out, 1 vote for 3 different posters. So the Google form is going to ask you for a nickname in case we have any questions about your vote. So it is still anonymous, but the nickname will help us if there's anything that we need to clarify for any reason. There shouldn't be, but you know, we like to be prepared just in case. For now, we are going to allow you time to go visit with the posters and the poster presenters. If the poster presenters could go into your room right now, that would be great. And Annie, give people about 15 minutes or so.
Yeah, I think that would be great. So it's almost the bottom of the hour. We'll want to start our plenary presentations. Will be starting at 10 minutes till. So the voting has now opened, but we'd love for you to interact with our all the folks that just presented. So you can go again into the room, kind of like if you attended the research showcase, go into each of those rooms. So if our presenters could join their posters, join the video, as Denise said. And so you may vote now or after you've had a chance to chat. And then after our two fabulous morning plenary speakers, we will announce the results. So if you have any questions, please put them into chat. Otherwise, feel free to go and say hi to our poster presenters.
Annie, can we get the link for the teacher voting as well? I think there.
Oh yeah, you should. At the top of, I will put that in there. At the top of Kiko Chat, they're also included. If you're in the Funding Friday main room, you could see tabs at the top. If you can see on my screen, there's a teacher poster voting and a member poster voting. So you can access them that way. But Susan, you said that we need a link to the member poster voting.
In chat, there's a link to the member voting, but there is not, I didn't see one to the.
All righty, I can.
I'll grab that.
Send that. Oh, you got it, Janice? All right. I could stop sharing my screen. Any other questions? Otherwise, I please would invite you to all go and talk to our fantastic presenters. Oh, look at, we're all sending it.
How do I get to the how do I get to the presenters?
If you are in the I'll put another link. So here is the Funding Friday. I'll share my screen again here. So here we are. If you go to the link that was just added to chat in the Funding Friday space, on the left-hand side, there are different rooms, and each of these, if you see poster 1, poster 2, each of those you can think of as a separate room. So if I wanted to see poster 1, I would click on it, and that would open a new video option to go talk to Mimi in poster 1. So you would join the video for that. And then you could just kind of move around to each of these and join, and so yeah. Any other questions from folks?
I don't think the teacher voting is in there. When I clicked it, it said member voting.
So
did we get the wrong? Let me make sure I'm here that I have the correct. Let me see. Teacher poster voting.
Yeah, I just dropped the teacher voting in again. I may have miscopied it.
Yeah, okay, because the last time it went to the member voting.
Oh, okay.
Yeah,
you could also access
the tab to copy, I think. It's the problem of having about 14 tabs open in one window.
Thank you.
You're very welcome.
Any other questions?
Annie, and then at what time do you want everyone to come back here?
We're going to have everyone should be back. We'll at 45, so we can then get ready for our plenary speaker. It doesn't matter if the Zoom for this and the other space, the other plenary space is linked, so they don't have to switch Zooms, but I think I'll do a broadcast. So if you were a poster presenter, you can find your way to the your poster so people can say hi to you.
But do we have to live here, right? To
Yeah, so you would leave here, but it would automatically take you there. So if you, for example, if I wanted to go into poster 3 and I click join video for poster 3, it'll automatically take me
Sure,
out of
thank you.
this Zoom into that one.
Great, thank you. And for the voting, for each group, we can have 3 votes, or combined, we only have 3 votes.
You have 3 votes for each. So you have 3 for a member and 3. So you could go use both forms.
Okay, great. So actually we have 6 votes. Okay.
You have
All right.
6 votes total, 3 in each category.
Yes, right. Okay, thank you. Thank you, Annie.
Annie, can you show me one more time how to get into these poster rooms? Because I've got the Kiko chat thing open, but I don't see.
Are you,
anything.
let's see, does your screen look like mine?
No.
Let's try
I
it again.
have.
So this is a slightly different Kiko chat space than the one you entered from the plenary. So the link that I am about to drop into chat, you'll need to click, or that Annie just dropped in. You'll need to click on that in order to see the poster list.
I'm good there now. Okay, I just didn't know how to get
I know
there.
sometimes Kiko chat can be a little confusing, but it seems to work pretty well for the most part.
And
Okay,
now
thank
do you see the posters to know what's going to happen next? And then
sure, happy to take over. I wanted to remind everyone that voting is closed, or should be closing momentarily. So scramble in and get those last Funding Friday votes in. We will be announcing the winners after our 2 award speakers. And thank you all for your active engagement with the Funding Friday presenters. And someone is asking for the voting links again. Annie, can you drop them both into chat?
Okay, I will put the voting links into chat one more time, and we'll say voting, I'm going to officially close voting at 9:55. So if you have last minute votes you'd like to get in, I will put both of them, but that'll be turned off at 9:55.
Okay. So I am really excited about these next 2 presentations, and I'm thrilled to be passing the MC duties back over to Susan, the ESIP Executive Director.
Thank you, Denise. Thank you, Denise, Annie, and all of you that put the time and the effort into creating posters and creating ideas. I just thought that was absolutely fantastic. The couple conversations I had time to have in the rooms just really exemplify the ESIP spirit to me. Really smart people with really great ideas who all just want to make a difference in our world. And sometimes, you know, when you read about more wildfires or more hurricanes, or, you know, it can get really hard. But when you come to a community like this and you see such amazing people wanting to make a difference, it just really gives me hope. And I really just, don't we need a little more of that in our world, right? So, and honestly, as I'm looking at these ideas, like I think some of these ideas are worthy of $3 to $5 million, not 3 to 5,000, but maybe the Funding Friday project can get these ideas on the radar screens, can be the incubator that lights a spark that starts something even bigger that goes on. And at ESIP, we'd be proud to be that initial spark that started something even bigger. So while we work on tabulating the results, I am really pleased to entertain you with 2 phenomenal plenary speakers. First off, it is my pleasure to introduce this year's Robert G. Raskin Scholarship recipient, Cora Van Hazinga. Cora is a graduate student at Salem State University. Her background is in geology and computer science, and she is passionate about furthering our understanding of geological processes using GIS and data science tools. Take it away, Cora.
Thank you so much, Susan. Let me share my screen here. All right, well, thank you so much for coming to my talk today. As Susan said, my name is Cora Van Hazinga. I'm a GIS master's student at Salem State University. That's where I also got my undergraduate degree in geology. I got my start at Bunker Hill Community College in Boston. Before I begin, I also want to thank my collaborators, Dr. Sarah Mana at Salem State and Dr. James Muirhead at the University of Auckland. I also want to say a huge thank you to the Raskin Scholarship Committee. Their support has meant so much to me and helped me in my research, and I've learned so much during this meeting. It's been wonderful to be part of the sessions. I really enjoyed seeing the posters and the research showcase, and I've been able to meet and talk with so many interesting people. So thank you guys so much. Today, I'm going to talk about my methods and the results of my analysis into the distribution and the morphology or shape of volcanic features found on Marsabit volcano in northern Kenya. This allows us to make inferences on the possible placement of magmatic constructs, in this case dikes. The orientation or trends of these features and the presence of linear arrays of these features indicate the locations and directions of dikes which fed these features with magma back when they were volcanically active. Dike placement is controlled by two factors: the accommodation of stress and the exploitation of pre-existing weaknesses in the crust. The cartoon on the left demonstrates how dike form in an extensional setting, also known as a rift. You can see how volcanic constructs form on either side of the rift, perpendicular to the direction of extension, that accommodates tectonic stress caused by the rifting. The photo on the right is an example of a dike that's exploited pre-existing fractures in the rock. You can see how it formed parallel to those fractures. This kind of analysis is important for a few reasons. Dike placement can tell us a lot about regional stress and the structural history of an area. The East African Rift, where my study area is located, is a totally unique tectonic setting, and new discoveries are made every year. The role of magmatic intrusions in continental rifting is still poorly understood, and the mapping and analysis of these intrusions provides valuable data. The rift is still a relatively young feature. It is imprinted over about 1 billion years of tectonic activity. This means that both factors that control dike placement could come into play in this setting. This method can be done anywhere with an internet connection and GIS software like ArcGIS Pro or QGIS. This is the next best thing to being in the field. Not every student or geologist is in the position of being able to disappear into the field for 6 to 8 weeks, whether that's for financial reasons, physical limitations, or pandemics. It's important to me to make geology approachable for everyone. This also lends itself to collaboration, which is also something I really enjoy. The East African Rift is the only active continental rift in the world. The African and Somalian plates are moving away from each other at rates that vary from 2 to 6.5 millimeters a year, which has really added up over the past 25 million years. The entire rift is about 3,000 kilometers long and is formed by a series of linked rifts and depressions. Rifts tend to have a high topography and narrow rift valleys with steep fault escarpments. Depressions tend to be wide and flat with no escarpments. The accepted theory is that the rift is occurring over 2 or more mantle plumes, which stretch and thin the crust, fueling the movement of the plates. A mantle plume is an upwelling of extremely hot material from the Earth's mantle that move upwards through increasingly cooler layers to the crust. In the northern portion of the rift, the heat from the mantle plumes have formed 2 high plateaus. Between these topographic highs is a low called the Turkana Depression, a really unique area within the rift. This is a wide, flat area with a very thin crust. It's only 15 kilometers thick in some places. It's vastly different from the narrow and steep rifts to the north and to the south. Below the Turkana Depression are the remnants of the Anza Rift, as shown in the map of Kenya on the right. The Anza Rift was active in the Cretaceous, some 55 million years before the East African Rift, and you can see it trended from the northwest to the southeast. This formed in relation to the breaking of the supercontinent Gondwana. I'm going to go into more detail about that in a little bit. Marsabit, Kenya, is a dormant volcano within the Turkana Depression. It's home to the Borana Oromo, Turkana, and the Meru people. The volcano formed approximately 13 million years ago with gentle, fluid-style eruptions called Hawaiian-type volcanism. This changed about 3.5 million years ago when eruptions became explosive and violent with lots of pyroclastic activity. Instead of erupting from a central vent or a caldera, hundreds of individual vents erupted on the slopes of the mountain. Marsabit's located over an aquifer, which has led to the creation of Mara craters. The image in the upper left is an example of a Mara crater. When magma comes into contact with groundwater, it results in a violent eruption that forms these circular craters. They range from a few hundred meters to almost 3 kilometers wide. Below that is an example of cones found on Marsabit. The image on the right shows all the mapped volcanic features on Marsabit. Superficially, you can see those features form a distinct belt that trends from the northeast to the southwest. I start by mapping each cone and crater on Marsabit with Google Earth Pro using methods adapted from Paulson and Wilson 2010. They pioneered this technique on volcanic fields in Antarctica, the western United States, and Hawaii. I outline the outer edge of Mar craters with the polygon tool. For cones, I find the change in slope using elevation profiles and draw the polygon at the point where the elevation changes. Google Earth Pro is really ideal for this kind of work. It's easy to change the viewing angle, and it's easy to upload polygons into other software. To ensure each cone and crater is accounted for, I divide Marsabit into 6 areas and map each area systematically over multiple sessions. After mapping in Google Earth, each area is compared to a shaded digital elevation model. After extensive double checking, each area is then reviewed by a collaborator. Sometimes, especially with cones, there's extensive erosion on one side. In these cases, idealized shapes of the features are traced in an attempt to capture the original shape of the cone. In cases of extreme erosion, there's no way to judge if the polygon's an accurate representation of that original feature. After mapping, each feature in polygon is assessed for reliability. If the polygon reliably indicates the shape of the original feature, the feature is given a high confidence score of 1 or 2. If the rims of the feature are unclear or eroded, or if the feature is really isolated, it's given a lower score of 3. After mapping, you can start the analysis. I start by establishing the minimum bounding geometry for features with a confidence score of 1 or 2. Ellipticality is established by finding the long-short axis ratio. If the ratio is greater than 1.2, the feature is considered elliptical and is a candidate for analysis. This is to rule out circular features. If a feature is circular, the morphology won't give an indication of the location or direction of the subsurface dike that fed the feature. If a feature is elliptical, the orientation will give an indication to the dike direction. The next task is to establish the presence of linear arrays, another sign of dike placement. My working definition of a linear array are 3 or more features within a specified distance threshold with near angles within 15 degrees of each other. It's easy to look at a satellite image and pick out lines of features. However, the human eye is not subjective or particularly reliable. My goal is to establish a scientific, systematic, and quantifiable method to establish linear arrays of features. My first step in identifying linear arrays is to establish clusters of features. This takes care of the distance threshold requirement. Kernel density uses the density of features to create magnitude per unit clusters, which then creates visual representations of dense areas. The image on the right is an example of kernel density clusters that demonstrate the concentration of Waffle House restaurants in the southeastern United States. The near angle tool is illustrated with the cartoon. A table is created that lists each feature, its 2 closest neighbors, and the distances and the angles between them. Here are the results of the feature morphology analysis. Out of the 618 mapped features, 184 meet criteria. That means the features have a confidence score of 1 or 2, meaning there's little erosion, and they have a short long axis ratio greater than 1.2, which means they're elliptical. The histogram and Rose diagram created from the data shows a strong trend to the northeast-southwest, a smaller trend from the east to the west, with a few outliers that are oriented northwest-southeast. I call these populations A, B, and C. I wanted to see if there was any pattern to where these populations fall on Marsabit, but they appear to be randomly distributed. Each population has a similar ratio of cones to Mar craters, so it's not the type of feature that influences the population. Ideally, it'd be great to get samples from each population and then date them to see if they erupted at different times. Now I'm going to examine the clusters created by kernel density and the resulting linear arrays. The kernel density analysis results in 6 distinct clusters as outlined here. Only features that lie within the shaded regions are considered. This accounts for 480 out of 618 mapped features. After examining the near angle tables, I can identify 81 linear arrays. That's 3 or more neighboring features in the same cluster with near angles within 15 degrees of each other. In the northeast corner of the map, clusters 1 and 2 only display northeast-oriented arrays. As you move to the southwest, other populations become apparent. The east-west trend, that's population B, is only visible in clusters 3 and 4. Here I give the trends of the linear arrays the same treatment as the feature morphology orientations, using the same population parameters. Just like in the feature shape trends, population A is strongly predominant. Both population B and C are minor, interestingly with the same number of features. So this is all very cool and interesting, but what does it tell us about the Turkana Depression? Are these 3 populations controlled by weaknesses in the crust or by extensional stress from the rift? As I discussed earlier, there are 2 known controls on dike placement: the accommodation of tectonic stress and pre-existing weaknesses in the crust. In the Turkana Depression, the rift is expanding east-west, which would influence dikes to form trending north-south. I don't see this in the data from Marsabit, leading me to conclude that pre-existing crustal weaknesses are the controlling factor here. Faults create weaknesses in the crust. The map on the right illustrates 3 fault zones in the Turkana Depression that trend in similar directions to population A and C. I also mapped the remnants of the Anza Rift, which still exists as basement rock below the Turkana Depression. The direction of extension in this ancient rift was northeast to southwest, which would have influenced rock weaknesses to form northwest to the southeast, just like the trends we see in population C in modern-day Marsabit. This leaves population B, the mystery population. There's no evidence of crustal weaknesses controlling the trends of these features, or evidence that they formed under tectonic stress. Further mapping in the Turkana Depression could shed light on the cause of those trends. So the theme of today's meeting is innovation, and that brings me to the next steps that I would like to take in this project. The first thing I'd like to do is explore the possibility of using object detection algorithms to identify and map features. Mapping can be tedious and it can take a lot of time. I've had limited success using Jupyter Notebook and the You Only Look Once object detection system, and we achieved a 40-ish% success rate, which is not terrible, but we were mostly limited by our lack of training data. The Raskin Scholarship is already helping me here. I'm taking a Python class over the summer, and I'd like to take more machine learning classes in the next year and learn more about working with Jupyter Notebook. I would also like to create a website that makes it easy to share mapping processes and literature reviews for published papers that use similar remote sensing and geospatial analysis techniques. This would also be an opportunity to share workflows for ArcGIS Pro, QGIS, and Google Earth Engine. A website could also encourage communication between students and researchers who may be looking for a common project and make it easy to share proposals for new study areas. For example, there's 2 volcanic centers within 100 kilometers of Marsabit that have never been mapped or analyzed. This could be the key for finding the controlling factor in population B. My biggest, and this is probably a little pie in the sky, would be the creation of a structural database for the East African Rift. I've chatted with a few people during the course of the meeting about my work with EarthD, a geochemical database for tephra datasets from East Africa. Tephra is a fragmented material, often ash, that's released in volcanic eruptions. Like these structures, tephra in East Africa has often been studied in isolation by researchers from different disciplines, and there's little cross-disciplinary communication between them. EarthD is working to create a comprehensive database of all the published tephra datasets, accessible to everybody through EarthChem. If we had a similar database, I'd like to include published and unpublished material, KML files, and similar. This could make it really easy to find volcanic features. We could include faults, lineations, and fold axis data. This could make it easy to analyze a large amount of data, either by location or by type, or maybe even age. This would really open the doors to lots of new projects and really further our understanding of the differences between structures in the rift, in the narrow rifts versus the depressions in the East African Rift. So thank you so much for your attention today. I'd really like to thank ESIP and the Raskin Fellowship once again for hosting me. This has been an incredible experience. I love meeting new people and talking about projects, so please feel free to reach out to me with any questions or comments. Thank you so much.
Thank you, Cora. Really appreciated your talk. If folks have questions for Cora, we have about 5 minutes for Q&A. If you could put those questions into the chat or the Slido link. And I was hoping to have a guest question moderator who has a little more geology background than me. Denise, any chance you can help us with the Q&A?
Sure thing. I'd be happy to. But first off, Cora, that was spectacular. I really enjoyed that talk.
Oh, thank you.
I appreciate you sharing your research with us. We do have a question here, and it's not completely about your science, but I think it's very interesting nonetheless. People are wondering about your journey from Bunker Community College to the amazing research you are doing right now. Because some of us have not had much experience with that sort of pathway.
I'm really proud of my time at community college, and I think community colleges are amazing. It's such a great way for people who haven't had a traditional path to really get into academia and expand their lives. I didn't go to college until I was 30, and I sort of impulsively signed up for classes at Bunker Hill, and my big dream was to work in an IT help desk. Like really, that was my big plan. So I did a 2-year program there, and I just loved it. It was amazing. I had the best professors. I had really fantastic projects, and I took a geology class that absolutely, it was amazing. I had the best professor. She took us on a field trip to an outcrop in a mall parking lot, because I think that was the only place like in driving distance. And we were talking about this glacial erratic, and I had this moment like, who knows where this rock is from? It's now here in this mall parking lot, and we get to bang it with a hammer and try to get little samples from it. And it was amazing. So from there, I transferred to Salem State University. They make it really easy to go from a community college to a state college. I'm still here for grad school, and it's been a journey, but I wouldn't have done it any other way.
Cora, I love that. I think many geologists get into geology kind of by happenstance, kind of like your journey. And I think it's so important to highlight that each of us has our own path.
Absolutely, yeah.
Thank you so much for sharing that. So another question, let's see. Is there a geological reason why the rift zones occur in the same general area of East Africa? And are there more historical rift zones than the 2 that you mentioned?
There are rift zones all over the world. One of my favorite ones is actually in the Great Lakes in the United States. That's a failed rift zone. When you start to know where to look for that distinctive 3-arm branching, they're everywhere. There is a theory that there were more in the earlier times when the earth was much hotter. There was a lot more of that slab push, pull, and convection going on in the mantle. As time sort of marches on, that is cooling a little bit and slowing. So right now, the East Africa is the only active one.
Okay, great. Let's see. Question from Ken Casey, our ESIP president. You mentioned the need to develop your Python and Jupyter Hub skills. Do you feel like your experience this week helped improve those technical skills or connect you up with people, resources to help?
It's definitely connected me with people and resources. I've crashed a couple of the machine learning cluster meetings, and those have been really fantastic. I love watching people sort of geek out about their projects, and it's been really, really illuminating meeting people and hearing them talk about their projects and sort of eavesdropping there. So I know at some point I'm going to go in and ask for a little bit more concrete advice, maybe classes I could take or online tutorials that would really help me out.
So two sort of related questions here. One person said that they'd love to connect with you as they've been developing an automated mapping tool that uses ArcPython. What methods have you tried so far? And someone else, you plan to approach AI machine learning, so they assume that you already have plenty of math data for you to start with training?
Sure. So we have 618 mapped features on Marsabit. I also was an advisor for an undergrad for her senior research, and she mapped a volcanic field in Nyambeni Hills, which is a little further south. So in our project, we tried to use all of Marsabit as training data to find features in Nyambeni Hills, and that's where we hit our 40% success rate. What I've been hearing is it's just more training data, the better. So my next idea is that if we can combine all of Marsabit and the 300 odd features from Nyambeni, then maybe we could apply that to another volcanic field, see if there's greater success. I've only worked with YOLO v2. Maybe there's some other different algorithms that might be a little better suited. I also want to play around with different false color combinations. We did one in that project. We're super lucky, and there is hyperspectral imagery in that area, which could really result in brighter contrast. So I want to play around with that and see if that can improve our training data as well.
Susan, how much more time do we have?
That is fantastic. Great questions, great answers, great moderating. Thank you both. I love hearing someone say they were crashing cluster meetings. But you're never crashing them. They're always open for anyone. And that's one of the really awesome things about ESIP is in just the year that I've been with the community, watching people who have been in this community for a decade or more are always happy to mentor folks that are new to the community. And it is really our goal to be an open, inclusive, welcoming community that is, challenging all of us to be the very best we can be. So crash all those cluster meetings you want to crash. It's not crashing. You're always welcome. With that, it is now my pleasure to introduce Ved Trieth. Ved is the Charles S. Falkenberg Award recipient. Ved is the director of the Laboratory for Advanced Sensing at NASA Ames Research Center, and I'm really looking forward to his talk. Take it away, Ved.
Thank you, Susan. Thank you all for having me. It was a real honor to receive the award. I have it sitting back there in case you're curious. It's quite a hefty thing, but excited to be here and to talk about some of the technologies my lab is developing. And please feel free to ask any and all questions. There's nothing too obscure. So my background is actually in astrophysics, and I moved into earth science about a decade ago. And I direct something called the Lab for Advanced Sensing at NASA Silicon Valley, just next to Mountain View. And hopefully here you can see my team. I just wanted to point out it's not just me, it's a large team effort. I've got Jared Vandenberg there, Dr. Alan Lee, Dr. Romina King, Jonas Johnson, Maria Kotenberg, a few other folks on our field campaign in Guam. But we do a lot of work out in the field and in the lab, and all of these instruments take a lot of human time and effort to generate. So I'll start off with why I moved from astrophysics and particle physics into earth science. And it really just came from a fact that's true today still. We've mapped all of these celestial bodies at a higher resolution than we have of our own ocean floor. And this is 2021. So that picture of the moon and the sun is something I took using a technology that later became fluid lensing. And I'll talk a little bit about that later. And we're now, on all of these celestial bodies, learning a lot about them, infinitely more so than we are of our ocean floor. So the focus of my lab at NASA really just became fixing this gap as priority one and developing technologies, not just for Earth and ocean science, but also for planetary exploration. So today I'll share just 3 different technologies, and you can ask questions about all of them. The first is Fluid Cam. This is a fluid lensing camera, and the first technology that I invented that can look through ocean wave distortion. So it's really giving us a fine scale view of shallow marine systems around the world. The second's a follow-on technology called MIDAR. This was just selected for NASA's Invention of the Year Award and is an active multispectral system that builds on FluidCam to get even deeper in the water and also go onto underwater robots and map the deep sea. And then finally, a technology called NASA NemoNet, which hopefully you have played. This is a citizen science crowdsourced video game that uses a neural network to classify data sets from FluidCam and MIDAR at a global scale. So I'll start with just why is it so hard to study the ocean and map the ocean? So NASA's viewpoint, our unique viewpoint and vantage point, is Earth and space observation. So looking from satellites down at the Earth's surface or from aircraft down at the ocean, there are certain frequency bands of light that actually penetrate the atmosphere. You can see in the top left. In astronomy, we use these bands in the radio, which is the atmosphere is transparent to. Unfortunately, once you get into water, everything is sort of absorbed. That's redder than 720 nanometers and bluer than 380 nanometers. So it's very difficult to see things at depth because after about 100 meters in the water, most of the light is absorbed and attenuated. The second problem, and this is something that's actually very simple to understand conceptually, you learned about refraction in middle school or high school. The ocean is a fluid and you've got a different refractive index of light in the ocean. So when light travels from air into water and there's a wave as well, that light can get bent and that causes severe reductions in effective spatial resolution. So if you have a flat surface and you're looking at something underwater, depending on your angle of viewing, the apparent location of that object can be different. That's problem number one. It's very difficult to study a system if you can't repeatedly make observations of it. And then the second issue is that the ocean is never flat. So once you have ocean waves, this becomes very, very difficult to image at fine resolutions. And right now, what we are finding is that this is the limiting factor in our understanding of the ocean floor. It's just even in the areas where light penetrates deep enough, shallow marine systems, which are the majority of the land area actually of the ocean, we cannot see things at a resolution that's fine enough or reliable enough to permit persistent observations. So things like coral reef systems are suffering as a result because we have very little data on how they're changing and the accuracies are very low. So to address this problem, I came up with something called the FluidCam instrument. This was born out of my PhD work in fluid lensing, and fluid lensing is a technology that allows us to remove these ocean wave distortions. So if you look at some of these test targets, you can see what a flat fluid case would look like in the bottom left. That's kind of what we're trying to get to. It looks like a brain coral. What we currently do right now are the top middle video or the bottom middle picture. So we can see these distortions. If you have a high performance camera and enough signal, you can see that video, but it's very difficult from that wavy image to discern anything reliable and measure something. Most of our satellites take the bottom middle picture. This is about a 1/10 of a second image, and those distortions start adding together and become very blurry. Fluid lensing is able to actually remove the distortions, but also use the positive magnification from ocean waves to get a high resolution picture of the ocean floor. And then it also tracks those bright bands of light you can see dancing around on the bottom. Those are coming from light focused by ocean waves, and they're called caustics. Those caustics can make the depth capabilities of the sensor exceed that of even a flat fluid case. So if you'll notice the bottom right picture, the fluid lensing integration and the flat fluid picture, they're taken in the same amount of time, but the fluid lensing picture has a higher resolution as well as a higher signal to noise ratio. It allows us to get deeper in the water column. That's because it's tracking caustics. So I've been deploying these technologies on drones and other aircraft around the world. This is from a campaign in American Samoa in 2016. And you can get an idea of what the image looks like on the aircraft. So this is a view of the ocean, the coral reef, and you'll see the reflections on top of all of the distortions. And then here's that fluid lensing view of the same environment. So this is right now the world record for resolution captured from above the surface. We validated this to a few millimeters in resolution. And it's a massive data set. We can map an entire island reef and get a diver scale perspective of that island. And then have a really good 3D data set for which to assess things like coral cover and what the ratio is of species in this environment. You can see a sea cucumber there in the middle top of the screen going by. That's about 6 inches in size for reference. Most recently, I got a breakthrough in the development of the technology, and we were able to get to a new depth of 45 feet with this. And we're going to be going again to Guam. This was from a Guam campaign to map the same area and try to get down to 60, 90 feet depth. Once you've reached that depth, you've covered most of the environment that humans live in and next to, and most of the shallow marine corals. And here's the kind of a comparison of fluid lensing to our other state-of-the-art satellite images on the left. Fluid lensing's on in tile B there, and you can see the depth map from fluid lensing, and then our comparison map is D, which is the highest resolution LiDAR map and sonar map we have of the same environment. So you can see the level of detail you're getting at a very large synoptic scale. We've also been able to introduce wildlife detection. So previously fluid lensing deleted a lot of the things in the water column. Now we can actually go back and detect everything that moved. And so we can get silhouettes of sharks and schools of fish and assess not just the benthic diversity and things that are living on the ocean floor, but also all of the marine biomass that contributes to the health of that ecosystem. Often just detecting sharks in a marine reef is a really good measurement of how healthy that reef is. The presence of sharks is good, the lack thereof is usually bad. So we've been doing field campaigns around the world with this technology, and then also trying to mature it onto higher altitude solar long endurance aircraft. So this was a test during last year of FluidCam flying on one of these high altitude drones. The idea is that these could deploy at scale around the world and persistently map some of these island systems that are very difficult to get to, even with satellites. You know, the access issues are quite severe, and it's hard to get good weather conditions over the environment. So instruments like, or platforms like this give us a new kind of perspective to view them. So FluidCam assesses that top layer of the ocean, that photic zone. Fortunately, the average depth of the ocean is 4,000 meters. And so there's a huge leftover piece of the puzzle for which we've been developing another sensor called MIDAR, and that's an active multispectral system that doesn't require solar illumination. And MIDAR is essentially the FluidCam as the receiver. That's the passive side of things. And then it's coupled to an active transmitter that illuminates the environment with lasers and LED diodes and different other technologies to provide structured optical illumination. So you can kind of see here our drone flying with the MIDAR transmitter. This is slowed down about 1 million times on the transmitter side. And essentially what we're doing is we're illuminating the targets with different spectral bands and then backing out an image from them using fluid lensing and MIDAR to get through the ocean wave distortion. So we can now map this as a Parietes coral in Guam in multiple spectral bands, day or night. And also we can send data in that optical stream. So in this case, we've transmitted a simple message, but as we go to explore more complicated environments where we're communicating with underwater drones or underwater robots, we'll want to be able to communicate through the ocean surface, which again absorbs radio, acoustically does not transmit beyond the ocean surface. So you really have to come up with new ways of sending that data in and out to get a good persistent map. So finally, I'll share a video of our NASA NEMONet program. This was really motivated by the data sets from FluidCam and MIDAR. When you map an island in 3D at the centimeter scale, it's a massive data set. One of our Samoa campaigns, just 10 square kilometers or so, is about 120 terabytes of data. When you get into larger islands, that can grow to a petabyte of data per island, and that's just not feasible to classify, manually. And even training in an AI to do classifications for benthic maps is very difficult because of the diversity in that environment. So we started off 4 years ago proposing this project, and then we launched it last year. And the idea was to use the NASA supercomputer to solve the problem of classifying these data sets and then also tying them to satellite data sets, so we can discern more about the environment at a global scale by mapping strategically coral reefs around the world at very high resolutions. So that then grew into a video game effort where we quickly were overwhelmed with just training the AI. And so now that AI is automatically trained by you, the citizen scientists. So I'll share this video real quick.
What if you could help NASA create a map of the ocean floor with just the tip of your finger? The ocean, teeming with life. It defines our blue planet, drives our ecosystem, and regulates our climate. Coral reefs are one of the most diverse and important systems in the ocean. They're also becoming an important source of medicines for some of the world's deadliest diseases. But they are dying at unprecedented rates due to rising temperatures. But we don't know how much we're losing or how much our climate is changing. We can't until we determine how much healthy reef exists now. And the only way we can know that is with your help. NASA NemoNet is a game where you classify the world's coral reefs by painting on real-life images scanned from the ocean floor using a revolutionary instrument that lets us see beneath the waves at unprecedented resolutions. Our oceans are so vast, it would take us 2 million years to classify the world's coral reefs by hand. The classifications you create are sent to our teams of NASA scientists at home base to teach our supercomputer to classify coral reefs on a global scale. Every contribution you make brings us closer to solving this problem. Join the NASA team to help us understand these amazing ecosystems. Take command of your research vessel and learn about all the different types of coral. We must keep the ocean alive. It supports our life as we know it. Together, we can create a global data set of coral reefs and build a better understanding of how to save these aquatic worlds, one piece of coral at a time. Good luck, and welcome to the NASA NemoNet team.
So we've launched NemoNet, unfortunately, during the peak of the pandemic last April, and it sort of, I think, as a consequence of that, just really became popular. We had over 300 million people in the first month accessing it from around the world. And the results, were that not only did we get really good training data for AI, but the engagement of communities, particularly those living next to environments that we were mapping that have a vested interest in their health and success, were really engaged at the grassroots level. So they could see their own environment, they could get an idea of what it looks like, and then contribute to mapping it. And these maps are going to be released late this fall as part of a global UN SDG 14 effort to help all these member nations track their marine ecosystems and provide sustainable solutions to conserve them. Just to give you an idea of the accuracy of the users, these are, users have to pass a tutorial they cannot advance in the game, where they learn about coral classes one at a time. And here's an example of just a few, I think 100 user classifications that are going into training the AI. So these are still filtered before we ingest them into the neural network. But it gives you an idea of the accuracy of assessing these systems in 3D at this resolution scale. They're incredibly detailed. In fact, often these accuracies exceed that of our subject matter experts performing the same level of training, which is really exciting and just a testament to how powerful the human brain is. And most of these people playing this are 11-year-olds and they're outperforming PhD trained scientists like myself. So as we develop these technologies, both the instruments as well as the automated ways of detecting life, we're looking at deploying these technologies to oceans beyond just our own, also in our solar system. So here's just some of the very cool ocean world moons we have orbiting Saturn and Jupiter. And we would like to get these instruments, under those ice sheets and exploring some of those oceans. In the case of Titan, it would be liquid hydrocarbon seas, which is quite exciting. So I'll leave you with some publications. If you'd like, you could scan that QR code and get an idea of how all of these things work. And I'd be happy to take questions. Thank you.
Thank you, Ved. That was fantastic. I selfishly speak for myself as a water person. I am grateful for these innovations. I spent 8 years on a NOAA Federal Advisory Committee where we continually talked about the charting backlog and the limitations of side scan and multi-beam. And, I was working with stakeholders that are in that near coastal area, in those shallow waters. And so I'm really excited to see these innovations and advancements. So thank you so much. Questions for Ved in the chat or in Slido would be great. I know that there was a back and forth while you were talking about how deep the MIDAR can penetrate.
Yes, yeah, I did see that in the chat. Definitely not 4,000 meters. That's the average ocean depth. But what we're doing is for daytime and nighttime observations, we're limiting the amount of light to what the sun produces per unit area, which is about 1,300 watts per square meter. If you multiply that over the sensor swath, you're talking kilowatts, megawatts of power. So we're right now at the 10 kilowatt power range, which can get us to a depth of about 45 feet at nighttime. And then we're trying to advance that further without introducing more light than organisms can be naturally exposed to. And then for deeper environments, we're putting this on underwater robots so we can map the deep seas with different wavelengths of light. One thing I'd like to point out is right now it's very unregulated. And I think that this is a big issue for deep sea ocean science. People go down there with incredibly powerful lights and they illuminate animals that have never been exposed to light in their life. So, the effects of that I think are not well understood. And MIDAR, the advantage is we can operate in wavelengths that are not visible to the photic sensors that we have evolved and other animals have evolved. So ultraviolet lights, or more in the red bands that are very attenuated at depth and not blind everything. So we're trying to be very careful in how we explore that environment to ensure we don't modify it and at the same time limit the contact. But right now it's basically limited to that power ratio. And thank you, Kate Rose, for playing NemoNet. I saw in the chat.
Another question here, what type of projection do you use for planets other than Earth?
What type of projection?
That came up, let's see, who asked that? Maybe Benita, did you want to clarify that?
Yes, hi, I'm Benita. So for Earth, like we use like Mercator projection to get the geolocation. So what kind of projections do you use for other planets?
Sure. So for other planets, we tend, and even at NASA, we don't tend to use the Mercator as much because of the distortion it has involved with the land area. So often we will just present two different spheres, and we'll provide a 3D mapping directly for that. Or there's sometimes for mapping efforts, we'll produce the orange slice version of a body, just so people don't think that one area is bigger than the other. Does that answer your question?
Yes, it does. Yeah, thank you.
Great. And I see a question here from Ken Casey. Glad to hear you're sensitive to the impact of things like MIDAR on the organisms. Do you have or envision any connection with operational NOAA seafloor mapping efforts?
Great question. Yes, we just had a new project called Picogram, which is a continuation of NemoNet with NOAA, which is a joint NASA-NOAA $4 million effort to operationalize NemoNet and hand it over to NOAA, which is the logical custodian agency to handle it. So we're working very closely with NOAA partners in the Pacific to ingest all of their 3D data, merge it with ours, and then give them the tool and the supercomputing expertise to perform that mapping themselves, and then it's handed off to them as a NASA tech development. Going beyond just fluid lensing mapping, we're looking at integrating all of the MIDAR data sets into that NemoNet platform, so that would sort of become the de facto global way of mapping, not just imaging, but also getting a habitat map of what you're looking at. Yeah, great question.
Another question just popped into Slido. Are you using, I'm not going to say this right, on-prem NASA computing to handle these huge data sets?
On-prem.
I'm thinking on-prem versus cloud.
Okay.
Correct? Whoever asked that question can clarify.
Yes, so the fluid lensing data sets are very intensive processing wise. So in fact, the FluidCam instrument was developed to process that data set on board, because eventually we wanted to put that into the package. It's in the CubeSat platform for low Earth orbit that we would deploy and hopefully have a constellation of fluid lensing satellites that could target reef environments around the world. So a lot of we spent millions of dollars trying to take FPGAs, merging them with GPUs and CPUs on board to do all that processing, so we don't have to share all of the raw data from orbit down to Earth. It would just be the post-processed product. Right now, for the aircraft that we're flying, it's just easy for us to pull that data down and process it, offline on the supercomputer or on our clusters or in the cloud. So we kind of use a mix of all of those. And then for NemoNet, we use the cloud to ingest all the data, and then we use the supercomputer to filter it.
Excellent. I hope that answered the question for whoever posed it. If you have a clarifying question, put it in there. Another question I have here, this is an interesting one. Can MIDAR technology help in locating missing airplanes in the ocean, like MH370 in the future?
That's a great question, and this just goes to show, how much we do not understand of a system that dictates our entire climate. We can lose jetliners in it, and launch global efforts and still not find them. So, just for a point of comparison, when we lost a probe on Mars that was the size of a car, it was found easily because of the access issue is non-existent. MH370, large jetliner, a huge amount of human loss, and we still haven't found it. We're hoping technologies like MIDAR can create something akin to a sustained marine imaging program, which I think we need. Just like we have a sustained land imaging program that tells us everything about land, we need a similar technology in the ocean that's going to require underwater robots, surveying things with optical technologies and sonar technologies like MIDAR and other systems. So yeah, I'm hoping one day, we will find this.
And then Steve Young has asked, are you exploring partnering with commercial satellite vendors like SpaceX and Planet?
Sure. So right now we have something called the Commercial Data Buy Program that Congress authorized NASA to actually buy commercial data sets and assess the quality. And we've been actively doing that for the last couple of years. So we're looking very closely at compatibilities and what's allowed and what's not allowed. There are certain IP issues, NASA's technology versus a commercial technology. And also, right now what we're not finding is the science quality that's needed for these kinds of environments on a commercial platform that's small. They're not driven by the same requirements as a NASA kind of mission. So often the effective spatial resolution, the quality, the signal to noise ratio is very hard for marine systems to operate on a light limited CubeSat versus something like Worldview 2 or NASA's Landsat or Sentinel, which just gives a very different kind of picture. So we are looking at that, and I'm hoping that either the commercial sector or the government sector will tackle this problem soon.
Yeah, and that's one of the things I love about ESIP is I love to see all of our NOAA colleagues piping in and really excited about what you're doing. And I love that ESIP is a place where cross-federal agencies, we can collaborate and share what we're doing, what we're working on. But then also bring in the academic and the private sector. So I love that all of that featured into your talk. So thank you so much for giving us your time today. Really appreciate it.
My pleasure. Thanks so much.
With that, I'm going to turn things back over to Annie and Denise to let us know where we stand on Funding Friday.
Take it over, Denise.
All right. The votes are in. Thank you all for voting and participating and interacting with all of our fabulous presenters for Funding Friday. I'm going to start by announcing the members who won. I'm pleased to announce that Megan, Ryan, and Thilanka all received our Funding Friday Award for members. If we can maybe give them a round of applause. And Annie, I think we'll be in touch with them about follow-up and details on what's entailed. Now we're going to go on to the teachers, and the teachers are near and dear to me. I've worked in informal education and I know how hard teachers work. And this past year has certainly, the past 18 months has certainly been particularly challenging with new things to face. And I've always been very proud of ESIP for hosting the teacher workshop and encouraging the teachers to get involved with ESIP as well. I know that there were some implementation grants awarded during the teacher workshop, small grants of about $500, I believe. And that's a great way to continue to support and engage the teachers. And so it thrills me to announce that Mimi, Eric, Jessica, and Becky all receive our Funding Friday Award for Teachers. They're supremely impactful awards. And I just, yeah, I'm sorry, I'm tearing up because I am so excited to see what's going to happen with these awards. Let's give those teachers a big round of applause for being engaged and supporting their students in really amazing ways.
Please feel free to unmute everyone and give our teachers a huge round of applause.
Thank you. Oh my gosh, I'm so excited.
Yes. And the enthusiasm that everyone had when presenting their projects was just, it's one of the reasons I love Funding Friday so much, is that I see people excited about new and different things and in a fun way and in a way that people get more engaged. So I am incredibly grateful for all the people who put themselves forward. And I am so thrilled that we were able to award all of you this Funding Friday grant.
Thank you, Denise. Annie, anything else on Funding Friday?
Just thank you to our participants. We could not be more thrilled with all of you being in the mix, putting yourself out there to have an idea and share it with our community and participate in this way. We are obviously very excited to be, back in person. I don't want to, knock on wood, next summer, and we could have a Funding Friday in person. But yeah, to all of our winners, I will be in touch. And just thanks to everyone for participating. And what an inspirational morning between the Funding Friday presentations and our last two talks. I just couldn't be, more grateful to be a part of this community. And I will pass it back over to Susan now.
Thanks, Annie. Yeah, to you teachers, thank you. I've seen in my own son's middle school science classroom the impact of a small grant, just igniting a teacher and changing the experience for the kids. So if we can help provide that in your communities, I'm really excited. I'm also really excited because there is a catch, right? You've got to come back and tell us how it goes. And I love those presentations when the teachers come back to a winter or a summer meeting and share with us the impact and what they learned, because we learn as much from you. So I really look forward to that. And to our partner member winners, I also am really looking forward to your projects as well. That those are going to start. Those are going to be some sparks that have some much bigger. I don't know. Maybe during forest fire season, I shouldn't talk about sparks, but we'll say idea sparks at least. But so thank you, everyone. We are not done yet. We have 6 more fantastic breakout sessions this afternoon. And I know that it's Friday afternoon, and I know that maybe the weather is beautiful outside, but please, I implore you to finish strong. But since this is our last time together as a large group, I wanted to do a few thank yous. I want to thank our agency sponsors, NASA, NOAA, and USGS. Their stable and long-term funding really makes this all possible. I also want to thank our meeting sponsors, Esri, Microsoft, and Element 84 for their financial contributions, but also their time, their people, their technology that they bring to ESIP. And I have to thank the ESIP staff who have worked really hard. There's so much that goes on behind the scenes that you don't see. The uploading of presentations at the last minute, the I can't log in emails, there's lots and lots that goes on behind the scenes, and this team is really phenomenal. I am super excited to announce that our next meeting will be in person and hybrid in Annapolis, Maryland, January 17th through 20th. I look forward to seeing you all here and hosting you in my hometown, Annapolis, and meeting so many of you in person. We will also be piloting various hybrid meeting technologies to expand our reach and to continue to engage with those of you who are not able to travel. If that is a topic that really excites you, I invite you to come and participate with the meetings committee, who will be helping to guide our decision making as we move forward in the months planning that meeting coming up in January. Later today, you will receive an important email with our meeting evaluation. Please make the time to complete this important feedback for us. Additionally, you can rate each individual session you attended on Schedule. This feedback is vital to us to learn from our meetings and to continue to innovate and provide you the very best meeting experience possible. And then remember that the work of ESIP does not only happen 2 weeks a year at these meetings. It is something that happens 365 days a year. We would love to have you engage in our committees and our clusters. Be like Cora, go crash a cluster meeting and then find your home and stick around for a while. If you want more information on how to engage, you can find all of that information on esipfed.org, including our community calendar. And you can reach out to the ESIP staff by Slack or by email if you need help getting connected. Additionally, we will have a webinar of the summer meeting highlights that should cover any sessions that you may have missed. And the recordings and the session materials will be made available online by August 10th. So thank you for giving us your time this week, and I hope you enjoy this afternoon's session.